Thanks to everybody for coming today. We have four presenters. We have been, since conferences are slowly coming back to normal, we've been having a lot more students present at conferences, but a few people have still had a little bit of trouble finding a good venue to present at. So these students are presenting seminars here with us, and they will be graduating this Saturday. So that's very exciting. Again, if you have questions, please ask them at the end of each presentation. And Dongyi, whenever you're ready, you can go ahead and start sharing.
Okay. So, hi, good afternoon, everyone, but actually it's my early morning in my time zone. So I will start my presentation. My name is Dongyi Zhao, and my advisor is Dr. Guler. So I'm so glad to finally presenting my capstone presentation today. As the topic of V-Carbon, designing a world CO2 emission observation and learning mobile application. So basically, there will be mainly a four part of my presentation: the background, objective, methodology, and results. So I will start with the background. Global situation. So the current global situation will be the simple but most important reason of why I'm doing why I'm selecting CO2 emissions as my topic, because I believe it is one of the most significant situation that the world is facing to. So for example, as we know, the CO2 emissions are seriously affecting the global natural balancing and the healthy, like including the effects on greenhouse effect, the ecosystem crisis, the sea level rising, and the natural disaster, and so on. Especially in the past of 20 years, a series of global issues shows that the greenhouse effect is seriously affecting the future of human beings. So based on the data of series of website, for example, from our World in Data website, the human activities contains a large portion of total CO2 emissions. The global carbon emissions generated by major electricity and heat productions activities, which reached around 14 billion tons, accounting for 41.7% of global carbon emission in that year. So we can see it is necessary to deliver the awareness of carbon emissions to the world. Also, based on another website, the net zero tracker data, there are out of the 135 countries pledging carbon neutrality, but only 66 of them have put a target year on their policies, laws, or propositions. So therefore, the reduction of greenhouse gas emissions is a key part of net zero concept to combating climate change. And finally, there are more and more worldly actions and plans are making CO2 emissions monitoring as the key goal. For example, the United Nations take the climate actions as global sustainable development goals as 13 positions, which deliver the central ideas of taking urgent actions to combat climate change and its impact. So the goals say the climate change is having profound consequences on our planet, diversities of life, and people's lives. So without action, the changing climate will seriously compromise food production in countries and regions that are already highly food insecure. So based on all of this context and background, the V-Carbon application aims to elaborate on the deliver a CO2 emissions learning application, which will able to query, visualize, and report the effective carbon emission status of each country and region, identify, compare, and analyze the performance of carbon emissions for each area, and then allow users to receive essential messages related to carbon emissions and take actions. So basically, with the use of this application, it will assist users in obtaining a systematic knowledge of carbon emission and learning about the status of carbon emissions in different country categories around the world. Methodology. So the data resource make a large part in this project, since the data analyzing and visualization are major deliverable in the final. So basically, the application will take the open source data from websites such as our World in Data, World Bank, Carbon Monitor, and the Climate Watch. So in the main features, most of the data comes from our World in Data website. So this website was created by the team from Oxford University of the UK. So through the website, the application uses the majorly of carbon emissions data from different regions, years, and industries around the world and form the data into the maps, charts, and tables to users to browse or download. And for the prototyping platform, I used a cloud-based prototyping software. So with the use of this software, people can like designing, prototyping, processing, and mind mapping for their creation and management. So basically, people can start from the mind mapping, record the flow of designing and doing the designing of prototyping, and then deliver the full design paper to the next develop procedure. So most of the files can be managed with this platform. Results. So now I'm introducing the main module and the platform of this application. As mentioned before, this application primarily focus on enable users to observe and learn about the carbon emissions data. So the V-Carbon application has two major functions: the knowledge graph and data observation. So similar to a knowledge tree, the knowledge graph concludes and summarize the most of current information and news about low carbon city. So with the knowledge graph, users can search or save the learning about the related information. And besides, the data observation is the core function of this application. So the data observation part allows users to select the specific year, regions, the type of categories, so that the users can visualize the map, conduct the charts, browse the data, or download the data. So go through the pages. Start with the welcome login page and registration. This is a simple design. Like we start with the page of a very first beginning page with a designing of a Earth as the background pictures. So it shows the importance of carbon city to the Earth and gave the sustainable development mind with this picture. So besides, users can also choose to log in directly or register on the next page. So as well, they can also reset or edit their password afterwards. And after that, So take the carbon emissions data. Let's take a example of South Africa in 2021, for example. So if a users want to use this application, so through the data visualization, it shows on the operation interface of touch screen. Besides, the time and the space graph are connected to display the information of the time and space distribution. So first of all, on the very bottom of the page, the website, I'm sorry, the application is designed with a fixed navigation bars, so which are to serve the common use of button, which are like the back to previous page, back to the home page, text hint, personal center, or searching and editing. So in the first of the step, um, people are people should define the category by time intervals first. So like the time of the year, the carbon emissions time, and the reason positioning. So for example, I'm selecting the 2021 South Africa as my target page. And then people are supposed to define the categories, which are like the building carbon emissions, the transportation emissions, or industry carbon emissions. So after all choosing the conditions, so data is transmitted to the front page through API port or server or something of the website. So in the meantime, users can choose the functions they want through the switch bar in the bottom. So they can realize um, the visualization of global carbon emission data with the map functions. Through the map, users can um, users can easily observe the world carbon emissions data distribution by just simply playing the map, as well as change the category from the top of the page anytime. So also in the navigation menu, users can also find the country profile, so they can see how different countries doing the reduce um, is doing in the category. Also, as well as the CO2 data explorers can help people to browse all of these metrics in the one place. So besides, people can also use line charts, pie charts, or bar charts to review trends of data variations. For example, the chart functions enables users to browse and download the detailed data. And they also can learn about the source and relevance of the knowledge and for the more further information. Also for the knowledge module, the knowledge module is related to primary information source website of low carbon city. So which stated above, such as Climate Watch website, the World Bank website, or Carbon Monitor website. So the knowledge module selects the main contents and most relevant information about carbon emissions and shares with users. Conclusion. So by the notion of low carbon city is originally appeared in the energy white paper, Our Energy Future, creating a low carbon economy by British government in 2003. So according to the white paper, it states low carbon economy aims to obtain more economy outputs based on less consumptions of natural resource and environmental pollutions, thus achieving higher standards of living and better equality of, of living. So same as my capstone designings, I'm wishing to use a just simple application design to deliver more awareness to people about the carbon emissions and low carbon city. So although I know this application is simple and the procedure of developing a application is hard process, so I'm still looking forward to try to optimize my design and find a opportunity to make it developed. So that is all of my introduce, and I'm waiting for more questions. Thank you.
Thank you, Dongyi. Great job. Does anybody have any questions? Feel free to unmute or to type them into the chat. You have a question there from Fritz. I'm not sure if you can see the chat. You might need to stop sharing if you can't see it.
Sure. Okay.
And if you can read the question out loud so that it gets captured in the recording, that'd be great.
Oh, yeah. Oh, yeah, I got the question. Do you think your application would benefit from getting feedback to help better design? Wait a minute. To help better design in interface and functionally to meet users' needs. Yes, things actually this design, I mean this capstone project actually is highly related to my job. So I'm working as a like application designer in China. So I'm very understand that the needs of the users are like the most like the first positions where we designing application. So if I got opportunity, I will like to create a quick demo of the application and like publish to the public and to receive more voice and feedback. So I think that will like mostly benefits of the application design. And I also got a question of what kind of metrics for success would you try to use evaluate this project with end users? Okay, for this question, so I think in the if this application will likely finally developed and delivered to the users, so I think in the end of the module, the most useful metrics for users are like how it delivered to the people. So for example, if we can publish it to the public, like more and more people can use it, I think that will be the best way for the objective of this design. Oh, I also got a question for use the database of Oxford. Did you download all of the data from that database and host it on the own system, or does your application dynamically query the data from its original source at Oxford? The database The database is not from the Oxford. I mean, in my conclusion part, I think I mentioned the low carbon city. I mean, the theory is firstly stated from the Oxford University, but the database mostly, I wish we can get it from like the open source database. So I think that will be the most, I mean, the most quickly way for the application operation. So I think mostly like in common develop procedure of a application, all the open source database are formed from a API resource and delivered to the machine. So I no matter is the cloud based or is the own like own system. So so yeah.
I think we'll cut it off there, Dongyi, just to not cut into other people's time.
Okay.
But great job. Maybe you can put your email address in the chat in case
Mhm.
anybody wants to ask you further questions. Now you can go to bed. As Anthony
Okay,
said,
thank you. Thank
yeah,
you
as
for all
Anthony
the
said,
question and thank you for your thanks.
yeah, very, very great that you were willing to be flexible and meet at this time.
Okay, thank you.
Good job. And next up is Justin Mitchell, who I believe it is noon his time. He's coming to us from Florida, so it's a little bit more reasonable. And so Justin, whenever you're ready to present, you can go ahead and start sharing. Don't hear you yet, Justin. So if you're, make sure you unmute.
Thank you so much. I got, a mute on my headset and a mute on Zoom, and I never get it right. So let me know everybody can see my screen, I believe.
Yes, we can see it and we can hear you now.
Okay, excellent. So my name is Justin Mitchell, and I had a couple presentations scheduled that were a little bit longer than this. So my PowerPoint has some stuff that I'm going to kind of glide over, but I'm going to give you guys some background on the project and then give you a short live demo of what I put together. So my name is Justin Mitchell. I'm a senior data scientist with a company called Black & Veatch, and we were pursuing a lot of projects related to the EPA's lead and copper rule revisions, and I started asking questions about how we were going to be handling other aspects of these compliance requirements. And I saw an opportunity to use my capstone as a way to develop a sort of suite of applications that are based in the Esri environment that we could offer to our clients. So, what we're going to go over is what the rule is, so you kind of understand why there's a need for program management, what the compliance requirements are, and then my solution and approach, and then we're going to do a quick live demo. So the EPA's lead and copper rule was published in 1991, and really all it was saying that you need to sample your water systems, right? So your city or your municipality, maybe a private utility provider, however you get water to your home, the people responsible for that had to sample their water. And if the water triggered above an action level or a threshold for the sampling, then you had to implement corrosion control methods, because lead pipes by themselves, they're not really that harmful, but depending on temperature, water chemistry, some other factors, they can degrade and then they can enter into the water system. So these corrosion control methods help to sort of prevent them, but they didn't. None of the regulations had any specifics about identifying lead pipes or replacing them. So in 2007, they made some enhancements to the rule, which basically set some quality control measures for the type of corrosion control treatments that were used and the frequency of monitoring. But it wasn't until 2021 that the first major revisions came out. And these revisions, known as the LCRR, they introduced regulations about sampling in school and childcare facilities, and actually requiring the water providers to identify and replace lead pipes. And then in 2024, the improvements, known as the LCRI, they're slated to be published. And it's anticipated that they're going to require municipalities to have a 100% lead service line replacement plan. So they don't want any lead in any water systems. So the compliance requirements, I've kind of already touched on these, but you know, the inventory requirements are unchanged. That, you know, you need to have an inventory of your service lines and the material. And here there's a graphic to kind of help you understand what a service line is. If you think of water mains and distribution lines as the interstates and smaller roads that lead into neighborhoods, the service connection would be the driveway. It's how the water gets from the system to your house. And it's separated by the public and private side at your water meter. Whether you know it or not, you've got a meter that, you know, measures how much water comes in and out. So the main compliance requirements are a service line inventory. So it needs to be publicly searchable, and it's required for all utilities and water providers, no matter how big they are. And you have to classify these service lines based on their material, their installation date, and things like that. Once you've got a draft service line inventory, they require you to have a service line replacement plan. So if you have even one pipe that you can, you know, identify as lead, or that you're not sure what it is, then you have to come up with a replacement plan. And that replacement plan also involves prioritization. So that means social justice things like disadvantaged neighborhoods, you know, historically underserved areas, and determining where lead is most likely. So that's where we get into some machine learning and predictive modeling, which is pretty fun. After that, we have our compliance monitoring plan, which is, you know, you've got your replacement plan. So now we're going to use that prioritization and that machine learning to try to predict where lead pipes might be and do some investigations where you actually go dig out part of the road and part of the driveway and identify the material. And we use that to feed the model. But in addition, we're still doing some sampling to, you know, try to identify areas that are testing above the trigger level. And you know, that would be a good place to, you know, try to identify some lead. We also are handling the school and childcare sampling plan, which is, you know, 5 samples at elementary schools and 2 samples at childcare facilities. So that could mean a water fountain, kitchen sink, bathroom, so on and so forth. And municipalities or water providers, they're required to sample at 20% of these for 5 years, so that after 5 years, you know, they will have all been sampled. Lastly, there are a lot of public outreach requirements. So, you know, like I said, the inventory needs to be publicly searchable. The EPA wants people to be able to know what their water providers are doing as far as what action they're taking. But in addition, they want them to be able to see, like, is my pipe lead? You know, those types of things. Local health agencies like, you know, FDEP, DEQ, you know, it's different for every state. There need to be annual reports. And then, of course, what's called the CCR, which is the customer confidence report. And if you don't know this, you can look up your city that you live in here in the United States and look up a customer confidence report, and you could see the results of your tap water. Like, should you really be drinking it, right? So we talk about a need for program management. Why is this important? So these utilities need to manage these new requirements. They need real-time compliance tracking because there are deadlines and timelines on all of these things, right? If you identify lead, within 24 hours, you have to notify the customer and provide them like a Brita pitcher filter for them to use. You have to coordinate with them to replace that lead pipe. Once it's replaced, 3 to 6 months after that, you have to provide a sample kit. You know, you need to follow up a month after you've provided the sample kit to get it back. If the results are above the action level, you have to perform a whole house flushing. So there's this really complicated compliance sort of cycle that happens. And we wanted to make sure that people weren't using tracking spreadsheets or sending emails. We wanted to build some, database logic using SQL and Arcade so that this was an automated process, right? And create some dashboards that really, drive the to-do list, as well as getting ahead of the public outreach stuff. Even though it's not required yet, the sooner you get ahead of it, and from a PR perspective, the sooner these utilities can kind of, help calm people down and let them know that they probably don't have lead pipes. And so that brings us all into data management being the key here. Providing referential integrity between all of the activity records that are related to compliance. And we want to help them with their asset management, even beyond the lead and copper rule. It's not uncommon for municipalities or water providers to have no GIS data. They don't know when things were built or what they were made of. So from this, we can help. My goal is to help people build an idea of, when things might fail, and do some things like that. So to build that draft service line inventory, what we're doing is we're looking at existing GIS data, if they have any. We're looking at their financials billing system for their water system, parcel and structure information, which I put twice because I don't know why. CMMS work history. So CMMS are systems that all types of government and non-government agencies, airports use to track work orders. So repairing a sign, fixing a valve. And so we're trying to look through all of these, do some analysis interpolation, and then we get a draft service line inventory that we can then feed to, the predictive modeling that we've developed. So I'm just going to skip through a couple of these slides because I'm, running short on time. But this is the idea of how I think a plan would work. We put together that draft service line inventory, do some predictive modeling. From there, we build a replacement plan. And then we start working on our compliance monitoring and sampling, our school and childcare sampling. And then by using these series of applications I've developed in 2024, when the actual rule improvements are published and all of this is due, municipalities won't be scrambling. It's already done. So for the solution and approach, we've set up some dashboards with real-time data to help drive your to-do list, right? So these dashboards, they inspire action, and they answer questions, right? Or they ask questions, right? We've made it to where there are user profiles for the public. If I thought maybe a utility might want to leverage consultants or contractors like plumbers who are having their eyes on the data. We have field collection apps. We did some user testing, and I'm developing manuals and training videos. And we're also, I developed some Python scripts that integrate the lead and copper platform with their existing GIS and work order systems. So if, someone has gone out and replaced a service line, then we don't want the lead and copper crew to go out there and inspect it. We already know it's been replaced by somebody else. So that integration is really important. We use, I developed some really complicated SQL queries with common table expressions and using, dates and statuses from multiple tables to come together and help, visualize both as indicators like, serial charts and number indicators, but also with symbology on a map of what the status is for these different compliance requirements. There's extensive use of arcade expressions for statistics, pop-up symbology, even customizing the dashboards, which I'm excited to show you. And lastly, creative integration of the existing Esri tools. Looking at all of these tools that Esri's provided in the ArcGIS Online environment and trying to figure out how we can put them together to, create something really great. So I'm going to skip ahead a little bit because, I want to do a live demo before I have take questions. But the evolution of the platform was started with just this in a PowerPoint. I was trying to figure out, different categories for the work activities and the compliance requirements and how different people would access our, the system. And my first draft was terrible. I was using parcels. This is actually a first draft, and it hurts my eyes and it hurts my heart to share it with you all. It's awful. So from there, I started thinking about, well, how are people really using this? And that's when I started working on some customization of the applications, giving people a little bit more context to the information. They don't have to go to an external location to, enter data. Then I started experiencing with multi-page dashboards. And this is when I was really looking at this and realized I was just kind of putting numbers on a screen. They didn't really mean anything. And that kind of leads us to where we are now, which is some really sharp looking dashboards that are easy to use and answer some good questions. So I'm going to go ahead and stop sharing my screen real quick so that I can switch and to my live demo. Let me know if you guys can see my my screen here.
Yeah, we can.
Okay, excellent. So the first thing I did was I used Experience Builder as kind of the template to develop these multi-page dashboards. And what we have are some snapshot dashboards that are loading slowly because my server just restarted. But the goal is to show the most important things first. Everything on this page requires action. In a beautiful world, these would all be 0. So if they're not, then that, as a project manager, as a task manager, you need to, set people up to take care of these tasks. So first we have the critical metrics. Then we have some summary dashboards. So for service line service line inventory, this is a fun little interactive way that you can say, well, I know the lead ban was in 1991, so show me all my pipes that are installed before then. And on the public side, I've got 61 unknown still. So that's something that I need to take into account. I need to identify these. We can further filter down and say, of these 61 unknowns, what's it like on the private side? So there's a lot of interactivity there. When it comes to the work activities, because we're short on time, I'm just going to show you investigations. So a field investigation or verification is just when you're going out and you're trying to see, what the material is, whether you're trying to, train a predictive model or whether you're trying to, respond to a customer. So we have these snapshot dashboards that give a high level of overview of where we're at. If you wanted to dive deeper, that's where we have our management dashboards. And the management dashboards I developed are universal no matter what the work activity is. And they're separated between status and coordination. So for status, we have these lists, which are driven by a really cool arcade expression that look at different dates and different fields. And they're smart. So they know that a private replacement was reported 77 days ago. So you need to verify this. And we know that it's in coordination and it hasn't been approved yet, which means that we still need to contact the customer. These are all filterable. So if the customer was not reached, we can filter up by there, and it lets me know that a follow-up call was required. By clicking on any of these, it'll zoom in, it'll give me a pop-up, and then I can see like previous scheduling records. So we called them on this day, we didn't get a hold of them. I also implemented a pretty cool arcade thing that pops up in Google Street View if you need to know where you're at. It basically just builds the URL using the lat long of the point. And when you click on it, it pops out there. So we know that we need to interact with this customer and we need to schedule something. So we can come to our coordination dashboard. And very similarly, we use this arcade script here to let us know, where it's at in the process. If I click on this, it'll open up. I've got to sign in, I apologize. And then right there, I can just say whether the customer approved. I can give like a couple dates. If they didn't approve, I can say why. If they weren't reached, I can just mark some notes. So there's a lot more that I built. There's some really cool Python scripts, but I really don't, have time. I think I've already gone over, to be honest. Nope, I got 2 minutes for questions. So yeah, I had to take like a 30-minute presentation and get it down to 15 minutes. So I apologize for kind of being a little speedy there, but that's it. That's what I've been developing.
Thanks, Justin. It looks like Anthony already has a question there. If you can't, you already stopped sharing, so you should be able to see it.
Yeah, so user feedback, number one, not everybody likes dark theme, I learned, but the main thing for user feedback was efficiency. So, if you're on this page and it requires the action of entering data, having people leave that page to enter the data was not efficient, and it would make people forget that they needed to do it. But really that was the most of the feedback that we got was that not everybody likes the dark theme like I do, and then efficiency. And that's how we got to where we are now, with those status bars and the arcade scripting, trying to help people understand what needs to be done right now, and helping non-technical people be able to accomplish their to-do list. Yeah, so this can be used to anticipate needs and allocate resources. And I wish I had time to show you, but one of the things that I used Arcade for was for inventory management. For example, we have to provide picture filters and sample kits, right? So I developed something that looks at the like a weighted, using Arcade to calculate like a weighted 6-month average of like how many sample kits have we used in the past 6 months, and then it dynamically creates a inventory threshold. So then if we drop below that threshold for sample kits or for picture filters, it says like, hey, we're going to need to order more of these. And when it comes to labor resources, the same thing. We can look at like, well, how many investigations do we need to do in order to make sure we're on track for compliance? How many have we done in the past month or past 6 months? So this is how much labor, we might need. And things like that. I don't know if that answers either of your questions.
Great. I think we'll move on, but if you want to put your email address in the chat, that'd be great. Might have some follow-up questions. But thanks, Justin. Good job. Okay, moving on. The next presenter is Isaiah Bashan. Go ahead, Isaiah, whenever you want to start sharing.
All right, just making sure microphone still.
Yep, still hear you. Yes.
Excellent. Sorry. So yeah, hi everyone. My name is Isaiah Bashan. I'm out in Colorado, so it's about 10:20 my time, not quite 1 a.m. And this is my capstone. It's a proof of concept geodatabase for to support
Isaiah, should we be seeing anything yet?
Yeah, is it not up? Darn.
No, we don't see it yet.
Darn. I thought I got it. Screen.
Oh, it looks like it's coming up now. There we go.
Okay. All right. So again, a proof of concept geodatabase to support invasive species management planning, specifically the site prioritization within Pennsylvania state parks. My advisors are Professors Gover and Detweiler and Dr. Saluski. Just the overview. So again, the abstract, this project has developed a proof of concept database to enable site prioritization assessment for the Pennsylvania Department of Conservation and Natural Resources Forestry Bureau in their invasive species management planning, or ISMP, activities within the Pennsylvania state parks. And it demonstrates the ability for a database to enable site prioritization, but also handheld field data synchronization. And there will be a brief demo a little bit later. So about me, I'm originally from Oregon, from Portland. A lot of invasive species issues in Oregon growing up. I've been interested in the environmental invasive species management side of things since high school. And currently I'm a DoD geospatial analyst, but I've been studying and working on environmental activity, including previous graduate work at George Washington University. And as a couple examples there on the right, many of my projects for the MGIS have been focused on invasive plants specifically, but invasive species. So brief introduction. Invasive species are a problem nationwide. There was an executive order introduced in 1999 defining invasive plants and providing kind of a way forward to work on them within Pennsylvania. You can see here invasive plants have direct impact across the community on native plant habitats, but also public health, crops, livestock. etc. Several of these slides have in the background, as you can see here, examples of Pennsylvania invasive species. So this is Japanese stiltgrass, kudzu, impacts within DCNR, and impacts of invasive plants. So DCNR's Forestry Bureau performs, assists, and enables the invasive species remediation. And they use this process called invasive species management planning to determine which habitat zones within parks have to be prioritized for remediation work. And as you can see, it's site specific, considers qualities of the management zones and the invasive species present. And so in this planning process, the Bureau or the individuals, the park personnel, they define values within indices that result in kind of a weighted score prioritization. And what had happened was that it was previously done through a workbook and not a GIS. Just here's some quick examples of the danger and damage of specific plants. And then, so like I was saying, previously the assessment portion and then the field remediation work were not digitally interoperable because the assessment portion was done in a workbook, an Excel workbook, whereas the field efforts and out in the field with the remediation crews was being done in a handheld in field maps or collector. So the goal here was to create a GIS side for the assessment portion. And now I've derived from the workbook tables and values to incorporate in the field maps. And as the last line shows, they do have in forestry, they have their own ArcGIS Online instance. They have many capabilities. They just couldn't do the assessment portion. So for a quick demonstration, apologies. My daughter. So in ArcGIS field maps, the field collection unit, the remediation crew, can pull this up on mobile devices, on tablet, iPhone, cell phone, and zoom into a defined habitat management zone. And through a relationship class between the polygon layer and the species, can add values. All of the species, the invasive species, are domain coded within the geodatabase so that there's no accidental, mistyping or fat fingering. And I don't know if you observed when I selected the values there, it did a quick calculations on impact, restoration, and priority. So these are all tables that are held within the geodatabase, and they are accessed, as Justin was discussing, via arcade script or arcade calculated expressions. So with the domain valued species identification and then domained extent values, which have meaning for the site crews, we can see that the priority of this the stream zone, the riparian zone, is a priority 9, which is the highest requirement to alleviate exotic biennials. One of the important pieces for me about this project, and then so sorry if I submit, now that is saved to the record. The one glitch I have is for some reason you have to retype the HMZ ID, even though it showed it to you already. But then if I go to another HMZ and add in even that same species, exotic biennials, with the same extent values, it's not as high of a priority because exotic biennials in this type of environment are not as critical as they are in like the riparian zones. So back to, so the solution and scope was to create a geodatabase. This was created in ArcPro, published it to the university's online service, then saved off as a service and a feature layer, and then saved as a web map. And then within field maps in the desktop ArcGIS Online, developed calculated expressions to output the site prioritization. The expressions are written in Arcade. And as you can see here, the reason Arcade is used is that it's custom and it's specific to ArcGIS applications. So unlike Python, which is useful for many other things, Arcade, it's portable across all the apps that ArcGIS does, that ESRI does, and it's specific to ArcGIS applications. As demonstrated, this proof of concept was just for one park, but that's mostly due to a manpower, time, and resource application. I believe it should be readily scalable to the rest of the state with just a little bit of additional input from the Bureau of Forestry. There is quite an extensive amount of literature about using GIS for invasive species management across the board, from regression models to predict rates of invasion, multiple decision criteria management, and then just that databases demonstrating county level distributions, et cetera. Another interesting capability that some folks use is what's called a floristic quality assessment, which really helps to demonstrate the impact of invasive species. I don't know 100% that this could be kind of up sampled, for lack of a better term, to include floristic quality assessments, but I believe the database has the ability to do that. So the goals were to create a proof of concept, and that was met, as demonstrated, that the prioritization assessments can be done through the field collection. However, the secondary goal was then basically accomplished because the assessments and field data collection can happen at the same time in field maps. And then really, for me, a big priority was the tertiary goal, which is to validate that this geodatabase and the resulting prioritization actually match the ISMP values for the selected habitat management zones in the park. And that has also been met. As I mentioned, it was creating a geodatabase in ArcPro, setting domains, defining a relationship class, publishing to ArcGIS Online, and then in the desktop field maps, creating Arcade calculated expressions. As noted, the layers, attribution, and schema are all modeled from the Excel workbook. And the real challenge I had initially was with the calculations to create the prioritization. However, lots of help from Professor Detweiler on getting Arcade, and Arcade really amazingly was able to, it almost seemed too easy once it worked. Now getting it to work was the challenge. Kind of a brief design flow of the creation to end use. So you can see here the domain values, the ArcGIS Online field maps. In here, you create expressions. These are all the expressions that call to the specific values and identify the features. And then here, examples of what the workbook has for habitat management zone input, species, and then the red, yellow, orange is the prioritization list. So as we saw, exotic biennials in the creek had a score of 9, whereas exotic biennials in the surrounding honey hole or campground areas only had a prioritization of 6. And then just some examples. This is the park in question here in Pennsylvania. State map, as you can see, the link for state map to cover it. This is the actual invasive species management plan output from Bureau of Forestry, and then the my map as output through ArcPro. And definitely a special thanks to the committee, Professor Gover, for the insight and development of the ISMP and the importance of being able to create a GIS solution for this. Dr. Leanne Chalewski for her advice and recommendations to scale into a proof of concept. And then again, for Professor Detweiler for all of his assistance with this capstone portion, especially working through the arcade issues. And then my references and any questions.
Great job, Isaiah. Any questions? So I have one from Ryan.
So Ryan asked, really slick application. Have you talked with folks at DCNR if they'd be open to adopting this type of application? Yeah, so full disclosure, I've been working on this since 2020. And in the interim, I had got a promotion and a new job, which really kind of killed my ability to multitask. But yes, in 2020 and in 2019, when I started with the program, I've been working with, or 2020, talking to DCNR. Basically, I think at this point, they'd be willing to get anything. So yes, I think they'd be very open to adopting this. From discussion with the lead folks and the Bureau of Forestry, it almost sounded like basically their response was kind of you don't want to look a gift horse in the mouth. Nobody's doing this work on their side. They don't have the bandwidth, staffing, or resources to do it. So the challenge here will be, potentially porting what I've created over to them and then scaling up. But most of the data is available on their end in their proprietary AGO instance. So I believe it's something that they could incorporate relatively easily. And like I said, they already use field map and collector. So another question is, does the tool have the ability to predict the rate of invasion? So no. And it's interesting from discussions with Professor Gover and the folks in forestry, it's not, that's kind of not what they're not worried about that, if that makes sense. They're really worried about what's there and what they can kind of remediate and remove. And so as demonstrated, it's at a polygon level. The collection takes place at a point level, so the individual lat long of where the plant is, but really it's not that they don't care, but the number of individual instances is less critical than the fact that there is growth of an invasive plant species within the specific HMZ. So I don't know that they'd really, that demonstrating the rate of invasion matters as much as proving that they can get to it and the impact. So I can see what you're saying, but I don't know that they would really do much with it. With a multi-user workflow. So the SDE server side, the next question was, how would the solution work with multi-user workflow? Is the schemas published to be based on AGOL cloud, or based on the SDE server? This is AGOL. It would probably need to be some further discussion or work on the DCNR side to see about getting to the server side. That is definitely my weakness, server side application. I believe it should be, well, time and money and manpower, right, to convert to the server side. And it should be allowed for multi-user workflow. It should be able to save off as edits are made. And then last question, have you considered integrating recent observations from iNaturalist? We've been using iNaturalist API to bring in recent plant pollinators for a bee mapping project at PSU. It's an interesting community complement to professional sampling. I think that website, I believe I've used for projects in coursework. And that definitely during the proposal side of this project was something trying to incorporate those sources, stuff that I can't remember the organization. I think it's actually the BLM or the Forestry Service, their natural species management information and the work they do. I think it'd be worth using. Again, this is more for the site-specific remediation done by the Bureau of Forestry. So if they were interested in doing that, maybe, but I don't think what I'm working on and what I've created would necessarily be able to handle that.
Okay, great job, Isaiah. If you want to put your email address in there, and we will move on to the last presenter of the day, Clint Henry. So Clint, whenever you're ready to present, you can go ahead and start sharing.
All right, good morning. How's everyone today? Or good morning, good afternoon for some of us. So, my name is Clint Henry, and I'm presenting my capstone project. It's entitled A Geospatial Analysis of Mortality in Relation to Proximity of Coal Mining in West Virginia. I work for an environmental engineering company here in West Virginia that focuses on permitting, mitigation, and reclamation of coal and other hard rock mineral mining. Before I start this, I want to go ahead and thank everybody who's attending today, and I appreciate your time, and also thank my advisor, Jennifer Baca, for her ideas, support, and encouragement. So with that, we'll get started here. The aim of this project was to investigate the impacts of coal extraction on the public health of communities surrounding impacted areas in the coal-bearing regions of Appalachia, specifically in West Virginia. It has been speculated that communities surrounding coal extraction operations are exposed to public health risks through air and water pollution. Until the mid-2000s, studies focusing on the health impacts of surface coal mining concentrated on miners, but few considered the potential downstream or downslope effects of communities or on communities surrounding these coal mines. Instead, it was surmised that health disparities in the region could be explained by poverty or lifestyle, like smoking and obesity. Since then, multiple scholarly articles have concluded that coal mining contributes significantly to higher rates of mortality due to birth defects, cancer, cardiovascular, and respiratory diseases among individuals living in coal-bearing regions of the area. However, some follow-up studies have been done that refute this, suggesting instead that the culprit is the health disparities found in this area. Much of the previous research has utilized population and health data aggregated at the county level, as that is the most common available distribution of public health statistics. But countywide studies discount the fact that population density and location of mining permits can vary widely within the county level boundaries, and that mining located near county borders is likely to have cross-county effects. This study attempts to address these issues with an examination of mortality in populations within the vicinity of surface coal mines using geospatial analysis to expose a more definitive correlation between mortality and proximity to surface mining operations. Specifically, this study uses a form of aerial interpolation called disometric mapping to disaggregate available population data into finer scale aerial units, utilizing ancillary data to guide the interpolation process and allowing for a better estimate of affected populations. So like Justin said earlier, I originally had a project presentation that was designed to be a little longer, so I've gone through this morning, in fact, and tried to shorten this up a little bit. So we're going to try to work through this kind of quickly for you. We're going to start with a little bit of history. In the eastern United States, Appalachia stretches from northern Alabama and Georgia to southern New York. The central Appalachian coalfields involves nearly all of West Virginia, as well as parts of Kentucky, Tennessee, Alabama, Virginia, Ohio, and Pennsylvania. Occurring within the oldest mountain ranges on Earth, it is complex terrain. It's characterized by steep slopes and deep gorges. Since the last ice age, the region has been mostly forested and is currently home to one of the most biodiverse and varied ecosystems in the world. Appalachia also contains some of the largest reserves of natural resources in the United States, including timber, coal, and natural gas. Surface mining, including mountaintop mining or mountaintop removal, began in earnest after World War II as technology improved to provide more sophisticated mechanization and means of excavation to include more powerful and larger haulage trucks and excavators. aided by explosives. This cheaper method of extracting coal allows for the extraction of coal from seams previously inaccessible to deep mining. And today, these surface mines span hundreds of acres across mountaintops throughout West Virginia and other parts of Appalachia, and excavate as much as 300 meters of mountaintop to expose deeper seams of coal. Despite declines in demand and improvements and advancement of mechanization, along with increasing price points of metallurgical coal, have continued to drive the expansion of mountaintop removal mining into the 21st century. Populations in West Virginia and Appalachia as a whole are known to suffer higher morbidity and mortality in relation to the rest of the nation. Cancer incidence in the Appalachian region is higher than that of the United States overall. The issue of cause is complicated by the abnormally lower salaries, higher rates of poverty, income inequality, older populations, lower percentage of high school graduates, higher rates of obesity, and increased tobacco consumption. This study intends to look at 5 dependent variables of morbidity that have been noted to be caused by particulate matter pollution that are of abnormally high incidence in West Virginia and were cited in other related studies on the health effects of coal mining on surrounding communities. These will include all-cause mortality, lung and bronchus cancer, respiratory disease, and cardiovascular disease. Surface mining operations, both contour and mountaintop, have significant potential to affect air and water quality. Water quality can be affected both by runoff from these mines and by the disposal of byproducts from the processing of coal. The exposure of rock and soil to oxygen and rain results in the dissolving of pyrite and the release of minerals, metals, and other chemicals previously confined in the rock. Surface coal mining impacts on water quality are well documented. The removal of forests and topsoil, the use of heavy explosives, and the heavy machinery used to excavate and haul rock and coal can create substantial amounts of particulate matter, or PM, which is a portion of air pollution that contains acids, organic chemicals, metals, soils, and dust particles. PM air pollution is the 13th leading cause of mortality worldwide, contributing to more than 800,000 premature deaths each year. Studies link PM broad cause of death mortality, including cardiovascular and respiratory disease, in the presence of heavy metals have been discovered in respirable concentrations of dust near coal surface operations. Sorry. Going the wrong way, my bad. The goals of this analysis is to determine factors contributing to high mortality in West Virginia caused by all cancers, lung and bronchus cancer, respiratory disease, and cardiovascular disease. These dependent variables were chosen because of their abnormally high rate of occurrence in West Virginia, their causational relationship with particulate matter, and because they were cited in a number of previous and related studies. Of the contributing factors, it is hypothesized that surface mining will be a primary contributor to mortality, and that as proximity to surface mining increases, mortality caused by the dependent variables will similarly increase. The primary question of this analysis is, do residents living within proximity of surface mining operations face increased risk of mortality? Additional independent covariables have been sought to explain or predict chosen mortalities. All data was aggregated at the county level. The data sets acquired for investigation in this analysis are shown here. In terms of analysis, one of the most important steps in this analysis and the process that is intended to advance the work of previous studies on this topic is the aerial interpolation of population data to smaller aerial units to better inform the affected population estimates. Many previous studies use a county-wide coal exposure measure that relates population exposure to total tons of coal mined in the county. Some use an even more simplistic binomial qualifier, for example, yes or no, in terms of associating positive exposure with having any mining within the community or the county. These methods do not contemplate the potential for exposure from adjacent counties. Additionally, previous studies show a correlation between mountaintop removal and surface mining to negative health effects within surrounding communities, but not causation. With the refinement of the data into smaller units, it is hoped that a stronger conclusion can be drawn between the location of surface mining and the populations affected. Spatial interpolation is a commonly utilized method in geographical research that uses values of known geographic points or area units to estimate or predict values at unknown points or area units. Often applied to spatial data, it's able to estimate values at a finer resolution than the original data. Aerial interpolation is a method of spatial interpolation using aerial features where the source data is insufficiently fine for the analysis needed. It is therefore interpolated from the source zones to smaller target zones. Ancillary data can be used in order to enhance the aerial interpolation in a process called disometric mapping. This approach utilizes related data as spatial control to guide the redistribution of data. In this analysis, disometric mapping will be used to redistribute population data from block group source zones to smaller target zones. The disometric method was created and used in the past to accurately portray population data or other data distributions, but has not been widely utilized due to the lack of publicly accessible disometric mapping techniques. Multiple methods have been devised, the most frequently used being reclassification of population by use of a land cover data set. This study employs a method which utilizes ancillary data to reallocate individuals. Building footprint data is used as the ancillary data to guide the process. Microsoft's building footprints were created using deep learning, computer vision, and AI to generate high-quality building footprints nationwide for Bing Maps and are available as open data. For our purpose, building footprints are an excellent predictor of population distribution at a much finer scale than is available with the existing administrative census units. The figures above here in this slide illustrate how this change affects the population distribution estimate. In figure 1 in the top left corner, a block group in Boone County is highlighted, this is in West Virginia, with the blue or cyan outline, and assumes representation of the total population with even distribution throughout the block group. In the second, figure 2, building footprints, highlighted now in cyan again, have assumed representation of the population. This shows the population for this block group is not evenly distributed throughout the block, and instead clusters around the periphery and northeast end away from the active mining. Active mining, by the way, is the light purple areas here and here. When estimating the effects of the active mining layer, again the light purple layer, on the population representations for figure 1, impacts are approximately 1/3 of the area, and therefore 1/3 of the population. In figure 2, active mining affects a much smaller percentage of the building footprints, almost none in fact, and therefore a significantly smaller population percentage of the population. This illustrates the basic concept of disometric mapping utilized in this examination. In figure 3, down in the bottom right-hand corner of this graphic, a half-mile buffer has been added to the active mining layer. That's the dark blue area. Again, in figure 3, we can see that while the half-mile buffer covers over half the block group, only 34% of the population, in fact, represented by building footprints is affected. Additionally, we can see where cross-county, or in this case, cross-block group effects are accounted for as mining in the adjacent block group up here near the top, that'd be up here, is affecting populations in the adjacent block group. Population exposure impacts are calculated by the percentage area of building footprints located within each buffer at a half-mile, 1 mile, and 2 mile increments. Once the aerial interpolation and disometric mapping process were complete, an investigation of the data sets was performed. This exploratory data analysis was done with the intention to improve comprehension of the data. Descriptive statistics and histograms were created, and a Shapiro-Wilk normality test conducted on both dependent and independent variables. Variables which showed significant skew were transformed using a log 10 transformation to increase normality. No transformations were conducted on the population exposure data. Next, we examined relationships through scatter plots and correlation analysis. Through this process, a correlation test was conducted using Pearson's method, and a correlation matrix was created. This process was intended to help us discover relationships of variables to each other, and more importantly, to the dependent variables. All dependent variables showed strong positive correlation with populations within a half-mile and 1 mile. As distance increase, correlation decreases. To validate what was discovered in RStudio regarding our hypothesis and the significance of surface mining on mortality, we ran multiple ordinary least squares regressions on the dependent variables and each individual variables, so independently. For the OLS regressions on dependent variables versus population exposure, without the introduction of covariates, population exposures at all distances were correlated and significant with reasonably strong R-squared values. As distance increased, population exposure variable coefficients, probability, and R-squared values decreased, indicating the effects of surface mining on all cancer mortality decreases with distance. Multiple regressions using OLS and exploratory regression tool in ArcPro were used to investigate all combinations of our variables for significance to the dependent variables and determine a model of best fit for our dependent and independent variables. In the final model, 5 independent variables other than our population exposure were chosen to explain mortality in our dependent variables. These were percent inactive, percent without a diploma, percent poverty, percent smoker, and percent minor. As documented in tables above, or here on the left, population exposure is positively associated for all models except all cancer mortality at 2 miles. Population exposure is not significant in any exposure distance for cancer mortalities generally. However, population exposure is significant for respiratory disease mortality and to a greater extent for cardiovascular disease mortality. Moreover, for all dependent variables, as exposure distance increases, it is shown that the significance of exposure decreases. This indicates that closer proximity of populations to surface and coal mining effectively increase the likelihood of mortality for all dependent variables, but more specifically for cardiovascular disease and respiratory disease. For this project, a novel approach to determining the potential exposure of West Virginia populations to surface mining using GIS is employed to address the question of how surface mining may affect those who live within the proximity of these coal mines. A disometric mapping method is devised using ancillary data to guide the redistribution of population to a new data set containing greater precision than is provided in an available data source. Correlation analysis indicated there was indeed a correlation between population exposure to surface mining and our dependent variables at each of the exposure limits. Using the Pearson's method, our values decreased for all mortalities as exposure distance increased, indicating that the effects of mining diminished as the distance from populations from mining increased. Ordinary least squares regressions were run comparing dependent variables to independent variables individually. The results indicated that for all population exposures, they were significant with P less than 0.01 to all mortalities, with adjusted R-squared values ranging from 0.32 to 0.5 at the half-mile exposure and 0.17 to 0.32 at the 2-mile exposure. Coefficient values, significance, and R-squared values decreased with increasing distance, again indicating the significance of proximity to estimating mortality. When controlling for other variables, as was done in our final regressions, the significance of the population exposure diminished as expected. However, the data supported the study's hypothesis, indicating that population exposure is positively associated with all of the mortality, all types of mortality, and that as the distance from surface mining decreases, its association with the selected mortalities increases. This infers that surface mining increases the probability of mortality in populations who live in closer proximity, and this is likely the result of exposure to harmful pollutants created by mining. The data shows that this to be particularly true for cardiovascular disease mortality and respiratory disease mortality, but is less conclusive for cancer mortalities. While it is believed this study accomplishes its goal to establish a methodology for developing a better population exposure measure, and it confirms that proximity to mining is a factor in predicting several mortalities, the conclusion is still correlational and not causational. However, this study does contribute to and support the greater body of work done in this area. Improving on the limitations of the study may help future studies improve on these results. And put some references in here if you can read those, but it's quick. And that is it. So.
Thanks, Clint. That was a lot of information. Are there any questions? Jim already has a question there.
All right. Question, nice work. Was there any kind of decision making on whether people lived in buildings or went to work, school there? I could imagine assuming that buildings larger than a certain size weren't residential, for example. And that's true. And I did contemplate that. There are some downfalls, I guess, in terms of that methodology. However, people spend a lot of time at work. In fact, probably at least a third of their life. So in essence, they are still occupying those buildings. And yeah, you got some areas too where buildings may have been left off because of tree cover. We've got issues with, some buildings being not inhabited at all. But I think in general, it gives a good representation of population, and certainly better than other options. Question here is, I really like how you use the building footprint data to guide your dimensional mapping. Did you find that the Microsoft data was adequately accurate? In other words, did you include all buildings or were many missing? That is a great question. I definitely believe that there were buildings missing. I think that in an area like West Virginia, I've used this building footprint layer for other projects that involve structures, and I've found that some structures are missing. Sometimes it labels things that aren't structures. Generally, it does a pretty good job. So. Great job including model results for distance derived variables alone in combination with covariates. Okay, thank you. Yeah, I think I think there's definitely some distance. I could probably take this a little further, and in fact, I intended to initially, but found that I had my hands full with what I had. Question from Fritz: did you consider examining the spatial autocorrelation of the buildings regarding population? If so, other kinds of regressions could be used to account for the spatial association between population data. I did not consider autocorrelation of buildings regarding population. However, I did do VIF on all of my variables, including those, and did not find any autocorrelation in terms of those items. So all my VIF numbers were less than 5. So although, I mean, early on in the process, when I had 12 variables, I had some that were in the 9 and 12 range, but those were removed, but not in terms of the buildings. I definitely looked at some other regressions we could have used, geographically weighted regression and fixed effects models, but again, didn't get to the point where I was able to use those. I think for the geographically weighted regressions, they just didn't have enough variables. I think you needed a larger number, or not variables, but sample size.
Okay, we are at time. Thanks, Clint. That was a great presentation. Everybody did a great job. It was a little depressing with CO2, lead, invasive species, and particulates from mining, but all definitely good things to be knowing a lot more about. So thanks to everybody. Congratulations to our very soon to be graduates. That's it. And I guess, Clint, if you want to put your email there, maybe somebody might have a follow-up question as well. But thanks again, everybody.